This video is about probabilities of independent and dependent events. First of all, let's talk about sample space. A sample space U is the set of all possible outcomes of an experiment. There are a lot of ways of representing or illustrating sample spaces, such as lists, two-dimensional grids, tables of outcomes, Venn diagram, and a tree diagram. In IB Math, we will talk about all these 5 ways of representing sample spaces. Probability of an event. A, P of A equals the number of outcomes of the event A over the total number of possible outcomes. We use NA over NU. N stands for the number of possible outcomes in A or total. Probability of a complementary event. We use A prime to show complementary event equals 1 minus the probability of event A. Let's go to guided practice 1. What's the probability of the arrowed marker finishing on the section marked with the even numbers? We could say how many even numbers here. It will be 4 out of 8. So we have 1 over 2. What's the probability of the arrowed marker finishing on the sections not marked 5? How many number is not 5? It's a 7 out of 8 numbers. This will be the probability for number 2. Compound probability is a mathematical term relating to the likeliness of 2 independent events occurring. Compound probability is equals to the probability of the first event multiplied by the probability of a second event. In other words, probability of A and B equals probability A times probability B. What's independent events? We say events are independent if the occurrence of either of them doesn't affect the probability that the others occur. So if A and B are independent events, then they do multiplication. Probability A times probability B. Let's talk about dependent events. Events are dependent if the occurrence of either of them does affect the probability that the others occur. If A and B are dependent events, then we have probability of A and B equals probability of A times probability B, given that A has occurred. Now let's do some practice for compound probabilities. 1. A box contains 4 red and 6 yellow tickets. 2 tickets are randomly selected from the box. With replacement. With replacement means you pick up one, then you put the back. Find the probability that both are red. Both are red means the first red times the second red. First red, we have 4 red out of 10. Altogether, we have 10 tickets. Since with replacement means you pick up one, then put the back before you draw the second time. So we still have 4 red and then 10 tickets total. We do multiplication, you will get 4/25. Let's go to this one. The first is red and the second is yellow. The first is red means 4 out of 10. Second is yellow. How many yellow? We have 6. 6 out of 10. So you get this reduce 3, 5, 2, 5. So we have 6/25. Now let's go to this question. One is red and the other is yellow. They didn't tell you, is it the first red or the second red? That's the reason you have to consider 2 situations. First of all, first is red. You have 4/10. Then second must be yellow. So we have 6/10. Then you need to plus. What if the first is yellow, then the second is red? So we get 12/25. When you're working on the problem of probabilities, you have to consider the possible outcomes. Like this one, you have to consider 2 situations. Then you add together to get the probability. Now let's go to B. Without replacement means you pick up 1 ticket, you didn't put the back. Find the probability that both are red. First, the red, we know that is 4/10. Second red, since you already took 1 red away, 3 red left. Total number of tickets will be 9 because you already took out 1 red. So we reduce. You will get 2/15. Let's go to second one. The first is red and the second is yellow. First, the red, that is 4/10. Second is yellow. Altogether, we have 6 yellow out of 9 because you didn't put back that ticket. So we reduce. You will get, here's 2, 5, 2, 3. So 4/15. Now let's go to last one. One is red and the other is yellow. Still, you need to consider 2 situations. What about the first red, 4/10 times? Second yellow, 6/9. Then plus, what if the first is yellow, then the second is red? So you get the 8/15. Second question. A bin contains 12 identically shaped chocolates, of which 8 are strawberry creams. If 3 chocolates are selected simultaneously from the bin, determine the probability that A. They are all strawberry creams. This word simultaneously means without replacement. Therefore, the first strawberry cream, that is 8 out of 12 times. Second strawberry cream will be 7 over 11. Because you took 1 away, 7 strawberry cream left and totally 11 chocolates times 6 over 10. Then equals 14 over 55. Now let's go to B. None of them are strawberry cream. So first one is not strawberry cream. It will be 4 over 12. You took 1 not strawberry cream away, 3 left, then over 11. Then 1 more is 2 left, and here's 10 equals 1 over 55. Now let's go to C. At least one of them is a strawberry cream. When we're working on probability C, at least, you have to do 1 minus probability of none of them is strawberry cream. Therefore, you will get 1 minus 1 over 55 equals 54 over 55. At least, when you do the probability, you have to do the subtraction. Let's go to number 3. The probabilities that students A, B, and C can solve a problem are 3 over 5, 2 over 3, and 1 over 2 respectively. If they all try, determine the probability that at least one of the group solve the problem. At least, that means you use 1 minus probability. None of them can solve this problem. Therefore, we do 1 minus. None of them solve the problem. For 3 over 5, that's complementary will be 2 over 5. We use 1 minus 3 over 5, that is 2 over 5. 1 minus 2 over 3, that will be 1 over 3. 1 minus 1 over 2, you get the 1 over 2. This is the probability not solving the problem. Therefore, we do 2 over 5 times 1 over 3 times 1 over 2. Then you will get 14 over 15.